Hey, welcome back. This is Middle School Math with Dr. K, and today we're going to start talking about solving equations when you've got equations with integers. That's your positive and negative numbers. We're not yet approaching fractions and decimals. Let's get started. All right, so I'm going to start with some one-step equations because they're relatively straightforward, and it's nice to talk about the process for solving in a short and sweet equation. Now, when I'm solving equations, I always recommend that you draw a line down the equal sign, and that's because an equation has two sides split up by the equal sign. So whatever happens on the left side has to be equal to whatever happens on the right-hand side. If it's not equal, we no longer have an equation, and that's a problem. Now, the whole idea for solving an equation is to get this variable isolated. That means we need it to be all by itself. So we use opposite operations to get our variables isolated, which means if my A has a plus 3 next to it, we need to do the opposite of add 3. We need to subtract 3. And whatever we do on one side of the equation, we have to do to the other side of the equation so that it's balanced, it's still equal, it's still an equation. Now, here's why that plus 3 minus 3 situation works out. If I have a positive 3 and I take away 3, I end up at 0. And that's the goal on that left-hand side. I want those 3's to, what we sometimes say, cancel out. I want to end up at 0 so that my A is isolated. Now, because I had to do the same thing on the right side of the equation, I no longer have negative 12. Now I have negative 12 minus 3, or you can think of that as negative 12 plus negative 3, which, as we know, is negative 15. Let's try another. On the second equation, we have b minus negative 5. And I wanted to show you that because in math, in at least middle school math, we would never let you answer a question or an expression as b minus negative 5. That's something that needs to be simplified. As you should have learned in your integer unit, taking away negative 5 is the same as adding the opposite, adding a positive 5. To that end, I would actually suggest rewriting that as b plus positive 5 before even solving. Then I'm going to follow the same steps I did in the first equation. I'll draw a line down the equal sign, and that helps me to remember that the equation should be balanced. Whatever happens on the left side needs to happen on the right side. Now my whole goal here is to isolate the b, that's our variable, and I see that I have a plus 5, and it will take a minus 5 to get to that 0 that I'm looking for on the left-hand side. 5 minus 5 is 0. We sometimes say that cancels out. It cancels out because it equals 0, not because it magically disappears. Now on the left-hand side, I'm left with just a b. On the right-hand side, I have 13 minus 5, which, as we know, equals 8. Here's another one-step equation that looks a little different. Negative 2c equals 12. Why I like this equation is because it doesn't have a plus sign or a minus sign or a multiplication sign or a division sign. You really have to process what's going on. Now, I like to say that the negative 2 and the c are scooshed together. That means they are stuck together. When that's the case, what that means is negative 2 is being multiplied by c. So we can actually add that multiplication symbol there just to help us remember that that's what's happening. Now in this case, the opposite operation isn't addition or subtraction. The opposite of multiplication is division, so I need to divide by negative 2 on both sides. You'll notice that I write my division like a fraction. That's an important process in equation solving. So I did not use the line with 2 dots division symbol, I used the fraction bar. It means the same thing, but it's an important way to show your work when you're solving algebraic equations. Now, with division, I'm not looking for a 0 any longer. What I'm looking for is to have 1c, not 0 c's, 1c. And I know that negative 2 divided by negative 2 is 1c, or c. On the right-hand side, 12 divided by negative 2 is negative 6, which gives me my solution. Here's the process that we're following almost every single time with every equation that we solve. Whether you're in my class or in another class, these are steps that could help you when you're equation solving. First, I suggest drawing a line down the equal sign, just like I've been doing each time. Now, eventually, you want to work your way toward not needing to do that, but it is, while you're learning equation solving, a really nice way to remind yourself that the left side and the right side have to stay balanced, and that line gives you a left side and a right side and makes that equal sign area very prominent. Your next step is to isolate the variable using opposite operations. So the opposite of addition is subtraction, the opposite of multiplication is division, and vice versa for both of those. Remember, you have to be sure to balance that equation. Do the same thing to the left that you do to the right. Now let's jump into two-step equations that are really similar to those one-step. We're just adding a little bit to the process. All right, here I have the equation 2d minus 12 equals negative 18. I'm still going to draw a line down my equal sign. I'm still trying to isolate my variable, but for now, I'm trying to isolate 2d. Eventually, I'll get to what 1d equals. Now, the opposite of subtracting 12 is adding 12. So I'll do that to both sides of my equal sign. Negative 12 plus 12 is 0, so I'm left with just 2d on the left-hand side. On the right-hand side, negative 18 plus 12 is negative 6. Now what makes this a two-step equation is, of course, I'm not done yet. I've got another step to take. As we remember from our one-step equations, if I have 2 and d scooshed together, that means that they are being multiplied. So when we don't see a symbol, we should automatically come to the conclusion that that's a multiplication situation. Now to undo multiplication, I need to divide. And again, I'm going to show that with a fraction line on both sides. I know that 2d divided by 2 would give me 1d, or just d. On the right-hand side, negative 6 divided by 2 is negative 3. Here's another. The difference with this equation from the first equation is that the variable's on the right-hand side. Sometimes that throws students for a loop, so I like to show you an example. Now, you'll see that I already drew a line down the equal sign. I already circled my variable. Those are the first steps I usually take when I'm teaching students that are learning to equation solve. Again, we're working towards not needing that eventually when you get really good at it, and that's great if you don't feel like you need it. However, I really suggest you start your equation solving journey following those steps. Now, I see that I have a minus 3, and the opposite of a minus 3 is a plus 3. Negative 3 plus 3 is 0. So on the right-hand side, I'm left with negative 10f. Again, that variable is on the right-hand side. Don't let it freak you out that it's different. It's really just a flipped version. We're solving using the same processes. Now, negative 10 is being multiplied by f because they are scooshed together. Yes, that's a very mathematical and official real term. Definitely not one that I just made up. Now, negative 10 is being multiplied by f, so the opposite would be to divide by negative 10. I'll show that with my fraction bar. On the right-hand side, negative 10 divided by negative 10 is 1, so I'm left with 1f. That's great. That's what we want. On the left-hand side, we've got something that doesn't divide nicely. Now, your options here are as follows. You can divide 25 by 10 and get the decimal form, which is 2.5. Now, I know that we were actually dividing by negative 10, so it's negative 2.5. Or another suggestion is to leave it a fraction, negative 25 over 10, and simplify. That's what I usually suggest my students do. Although fractions can kind of be scary for some students, it's a little bit easier sometimes than long division. All right, here's one last equation. This one's a little different because of where this variable is, but we'll get there when we get there. I'm going to go ahead and start solving. I drew my line down the equal sign. I circled my variable. I see that there's a minus 9, so I need to add 9 on both sides. Now on the left-hand side, negative 9 plus 9 is 0, so I'm left with g over 3. On the right-hand side, negative 4 plus 9 is 5. Now this is where things are a little different. G is over 3. It's written like a fraction, which, as we know, when you have that fraction line, that's showing division in an equation. Well, the opposite of division is multiplication. If I multiply both sides by 3, on the right-hand side, I can see that I get 15, but what's happening on that left-hand side? So I'm going to go off to the side and show you. I have 3 over 1 times g over 3, which, if we were just multiplying regular fractions, we would multiply the numerators and get 3g, and the denominators and get 3. And we know that 3g over 3, 3g divided by 3, is 1g. Now here are those steps for equation solving again. I added one more step just because we're now looking at both one and two-step, and two-step equations are just a little bit more complex. I suggest drawing a line down that equal sign for a few weeks while you get used to equation solving, even a few months. If this is a new skill for you, that really helps you get your mind wrapped around the balancing situation. Whatever you do to the left, you do to the right. Now, your goal is to isolate the variable using opposite operations, as we know. And this third step that I added is work your way toward the variable. That means if I have a 2x, let's say plus 3 equals 10, first I'm going to start with the thing that's not right next to the variable. I'll work my way toward the thing that's right next to the variable. The same is true if it was x over 5 minus 6 equals, let's say, 12. I'm going to work my way toward the variable, which means I'm going to deal with my minus 6 first, and then I'll deal with that 5 that's attached to the variable. Whatever's attached to that variable should go last. The last step is to be sure you're balancing the equation. Whatever you do to the left side, you gotta do to the right side. That's how it stays an equation. That's how it stays equal. So I hope this gives you some skills to pull from when you're equation solving in class, out of class, wherever you are. I'm glad you were here, and I'll see you next time.